For those of you interested in the PIN product, we are going to look at its performance on a first principles simulation. There will be 4 simulations, each with varying degrees of disturbances. Here we see the process we are simulating. The control objective is to maintain both discharge temperature and flow rate as their set points are changed during operation. The process has a control valve and a temperature and flow measurement for each hot and cold water source. The hot and cold water sources are uncontrolled and will have different degrees of temperature variation. The first example has stable hot and cold water source temperatures and both valves operate as designed. In our HMI, the source and discharge water temperature trends are in the upper left. The discharge flow trend is in the lower left. Both discharge temperature and flow set points are shown with a black dashed line. The hot and cold valve positions are shown on the trend to the right. With stable source temperatures, the control valves move smoothly to maintain both set points, even with aggressive set point changes. In our second example, both hot and cold source temperatures are variable and both valves operate as designed. For comparison, we use the same set point changes as before. Notice the variations in the source temperature in the upper right. The trend shows the discharge temperature and flow track their set point, but as can be seen, the valves have to work a little harder. In our third example, the hot and cold source temperatures have a high variation. We've also introduced stiction in our control valves and transmitter drift and noise. The trend still shows both set points being maintained. As can be expected, the higher source variation with addition of valve stiction and transmitter drift and noise has caused the valves to work much harder. Our fourth example demonstrates the trajectory control of the controller. The temperature has been set up to have a first-order trajectory of 100 seconds. The flow is set up at 10 seconds. Observe the graph showing the relative trajectories after a step change. Next, we'll change the flow trajectory to 100 seconds and review the graph. As the trend shows, the trajectory of the flow has changed to 100 seconds. It should be noted that the data files developed for this simulation used the same neural network significance analyzer and model trainer described to produce a virtual instrument. If you missed something, please rewind the video and watch it again.